Water self-ionizes, which means that it produces the hydronium ion and hydrox ion, but it doesn't do it by very much. So again, the hydronium ion is H3O plus, the hydroxide ion is OH minus, and this is formed when you either gain or lose a proton. How often does this happen? Well, 1 out of 10 to the 14 molecules self-ionizes. So we have a constant here. The constant is the concentration of H plus ions times the concentration of OH minus ions equals 1 times 10 to the negative 14. In other words, if we have equal numbers of hydrogen ions and hydroxide ions, we have a constant of 1 times 10 to the negative 14. This is the reason why pure water has a pH of 7, because it has equal concentrations of both, but they're so small that it's not read as either an acid or base. In other words, pure water is neutral. The acceptable pH range for drinking water is between 6.5 and 8.5. The reason why is because they add additives to purify this water or to add additives to help with cavities. Sometimes pure water or water becomes hard by accepting calcium carbonates from minerals, from rocks that it picks up when it's in these reservoirs. And this is what makes the pH either increase or sometimes decrease depending on where you are. So how to calculate the concentration of H plus and OH minus ions? Well, we know that the constant 1 times 10 to the negative 14 is a constant which tells us that 1 out of 10 to the 14 molecules is going to be an H plus and an OH minus ion. So in order to find the concentration of H plus, we take 1 times 10 to the negative 14 divided by the concentration of OH minus. Same is true with the OH minus. We're just going to divide 1 times 10 to the negative 14 divided by the concentration of H plus to get the concentration of OH minus. Acid-base characteristics. Well, another characteristic would be its pH, and pH determines the nature of the solution. We know acids have a pH of less than 7, therefore its concentration of H plus is going to be greater than OH. Neutral, it has a pH of 7, which means the concentrations of H plus and OH minus are equal. And bases have a pH of greater than 7, which means it has a higher concentration of OH minus ions than it does the H plus ion counterpart. pH and pOH, well, pH is a negative logarithm of the hydrogen ion concentration. In other words, it measures in concentration how much is in there per liter. And we go ahead and here's the formula. pH equals negative log of H plus ions. Now remember, the H3O plus can also be marked as H plus ions. So it could also be written as pH equals negative log of the concentration of H3O plus. pOH is the same. We want to know the concentration of the hydroxide ions. Okay, and it's again the negative log of the OH concentration. The relationship between pH and pOH is pH plus pOH equals 14. Here's an example problem. I want you to find the pH given these two concentrations of H plus and then determine whether or not you have an acid or base. Well, using this equation, negative log of H plus, you should get a pH of 10.18 for the first and 2.48 for the second, and this indicates whether or not it's an acid or base. And the first equation is a base because it's greater than 7, and the second one's an acid because the pH is less than 7. Taking a look here, I give you the concentration of OH minus. From this you can get the pOH. From that you can get pH and then determine whether or not it's an acid or base. Again, using negative log of concentration of OH, we can get the pOH. From pOH you can subtract that number from 14 to get pH, and from there you can get acid or base. When you do those calculations, you get 5.47 for the second, 7.08 for the 5.47 for the first, 7.08 for the second for the POH. Subtract that number from 14 and you get 8.53 for the first for the pH and 6.92 for the pH for the second, and therefore you can determine whether or not it's acid or base based on where it lies on the pH scale. Now, how do I figure out the concentration of H plus or OH minus? Well, the reverse of log, or the negative log, is taking 10 to the negative exponent. And in this case, if we want to find the concentration of H plus ions, we're going to go 10 to the negative pH as an exponent. OH minus is the same, 10 to the negative POH. From there, I can figure out concentrations of each by dividing by 1 times 10 to the negative 14. Here's an example. Fill in the table. Well, from there, I can figure out acids or bases. Here's my answer for 1, 2, and 3. From column 1, I can also figure out the concentration of H plus by taking 10 times negative 3.8, okay, and I get 1 times 10 to the negative 6, or 1.6 times 10 to the negative 4th as an answer. Same is true for problems 2 and 3, and from there I can figure out the OH by dividing these numbers into 1 times 10 to the negative 14, and I get these values.